Okay, guys, welcome to indeterminate form and L'Hopital's rule. Hopefully, you guys remember indeterminate form back from the beginning of the year when we were looking at 0 over 0 and infinity over infinity. What that really meant to us, if you remember back in September, was that it meant more work. So take a second and see if you can remember the 3 extra things that we could do when we were dealing with limits back in September. Sorry, let me turn that off. So the first one, hopefully you're a little bit ahead of me trying to remember this. It was factoring. So that's one thing we could do. The other thing was, rationalize the numerator. I'm sure some of you guys were thinking this. And then last, we looked at this a couple different ways. Some of you guys said combine like terms. A lot of times it involved fractions, and we are really getting a common denominator. And again, this was how we described it in class. It was what made sense to you guys. So now we're going to look at limits. And if you read the email I sent out earlier, this is the one section that will be on the AP test that we did not cover yet. So I want to make sure that you guys can work through this pretty well. I think that you won't have a problem with this really at all. These worked out solutions are also online if you just want to listen now and go back and look at the filled in ones later. Again, whatever works for you. So if we had this, and let's go back to September, and if we saw this problem, or let's pretend we see it on AP test, like what would your first thought be? And we always had to do this first. And it would be direct sub. So if you go ahead and sub in a 0 and a 0, you guys will get 0 over 0, which is one of the indeterminate forms. And again, that means that that gives you no answer and that you have to do more work. If you look above at your factoring, rationalizing, and the common denominator, none of those work here. So in this case, we picked up our calculator and started finding some values. There's a couple ways to do this. On the video, I won't spend too much time plugging these in, but just to review with you, a couple calculator shortcuts is, let's make sure this shows up. So if you go to Y1, let me clear this out, and if you type this in, remember to get the fraction. If you hit alpha y equals, enter, it gives you the fraction bar. So up top, we have second e to the 3x minus 1 all over x. And then we can just refer to this as y1. And if we get out of this, you can either use the variable key or you can use alpha trace. If you hit alpha trace, it gives you the y1. This is, I think, a little quicker than the variable key. So again, that was alpha trace accessing this. So now we're going to plug in a couple numbers in a second, but let's go back here and let's say when we plugged in 0 over 0, we got no answer. It was really D and E. So if we go over, this will be the middle value. So let's put a 0 in here, and we got D and E. So summing a value in didn't work, so now we're going to look at it from both sides and kind of see where we're at. So let's creep up on it a little bit. So let's start maybe by subbing in a negative 0.1 from the left. And we get 2.592 rounding to 3 places. So a negative 0.1 gives us 592? Okay, and then if we go and do the same thing again, and again, I'm not going to show this every time, you guys can practice it, but it's just hitting alpha, trace, enter, and then now if we sub in 0.1, we're at 3.499. So if we're over here now, from the other side, we get 3.499. So you can see, let's see if we can get these both on the screen. If you're looking at this, that they're pretty far away from each other. If we keep getting closer and closer to our target, which is 0, what would happen to the data? So if we get to 1/100th, we get 2.955. That's on the negative side. On the positive side, we'll get 3.045. Right away, you can see the numbers are starting to converge a little bit. If we go even closer, we'll get 2.996, and then over here, if we're at 2 zeros with a 1, we get 3.005. And a good guess would be, of course, it's getting into 3, but you want to be spot on. So I would go even closer. Let's see this last value I subbed in, 1, 2, 3, 4, 5. I put 5 zeros and a 1 on either side. and the calculator rounded to 3. So then we're pretty confident that looking from the left and the right, that the left and the right meet up. So at 0, even though we did direct sub, it didn't work. Our algebra methods didn't work. But again, the calculator showed us that we got a 3. Okay, so the reason that we went to the calculator is because the algebra doesn't work. Okay, going on to the next one. Again, we see natural log. Algebra is probably not going to work here. Even if we get a common denominator, we're going to end up with a natural log up here. Nothing's really going to simplify. If we try direct sub though, so even though it's coming from the right, remember if 1 works, then the right and the left have to be the same. But if you try subbing a 1 from the right in, remember natural log, you guys want to have that graph memorized. And it hits at 1. So if you're coming from the right, this is a teeny tiny number. So we have 1 over super small is super big, which gives us infinity, minus, remember this is the one that we would write like think off to the side. So you don't want to show subbing it in, but just to kind of get a feel for what's going on, think of 1.001 minus 1 is super small, 1 over super small is really big. Now, if you have infinity minus infinity, it seems like that should be 0, but it's really not. Because what if one infinity is slightly bigger than the other? Then we don't know what the answer is. So just remember this is not equal to 0. So this is another indeterminate form. Because it's indeterminate, again, that means more work for us. Because we're looking at 1 from the right, you can see like up here, I looked at from the right and the left because they did not specify. Right here, it's just from the right. So when I sub a 1 in, we got does not exist. Direct sub did not yield a value. We got an indeterminate form. Means more work. Our algebra stuff doesn't work, so we start plugging numbers into the calculator. I'll go over one of these with you. So let's see. Did I need this? 1, 2, 3, 4. So start over here. If we start a tenth away, we're going to end up with 0.492. And again, verify this all in your calculator. I just don't want to take time up on the video doing it. But same thing before, type it in Y1 like we did. And then you just type Y1 and then the value you want. Okay, so you're going to get, if you then go in a little closer, you guys will get 0.499. 1.001 is 0.5, and then 1 point, let's see how many zeros I used here. 6, 2, 3, 6 zeros. And then we got 1/2. Okay, so looking at these, you can see it started like it was almost at 0.5, got closer, and then as we were right there, we're pretty confident that the answer is 1/2 now. Okay, the last one, here's another weird indeterminate form. As x goes to infinity, 2 over infinity is, remember, it's close to 0, not quite 0. So we're going to get, for all intents and purposes, this is 1, and 1 raised to infinity is another indeterminate form. Think of it this way. You have, like, it's really 1.001. So just over 1 raised to a huge power. It's kind of hard to say where that's going. So going to infinity, start subbing some really large numbers in. I did 2, 3, 4, 5. I did 6 nines. And I got 7.389. I then tried 7 nines. And I got 7.389. Pretty conclusive. That's my answer, 7.389. Today, though, we're going to look to say, well, what if we didn't have our calculator? And we'll look at how to do these using L'Hopital's rule without our calculator. So this was a quick review. Again, I skipped showing the calculator work on B and C. You can go back to A if you need to see it. Okay, so now what if we had these guys? So this was using algebra from earlier. Take a second to answer this. What's the first thing that you should always try? And hopefully you said direct sub. This gives you 0 over 0. Indeterminate means more work. So that it says here to use algebra. Look up above. What algebra would you use? And it would be factor. So as x goes to -1, you can take the 2 out. You get x minus 1, x plus 1. So this is a good review of chapter 1, too, since your test is coming up. And looking at this, you can see that the issue was subbing a -1 in here with a 0 on the bottom. Now, lucky for us, those go away. When you sub in a -2, you'll get -4 as your answer. Did not need the calculator here because the algebra worked. Going on to the next one. Infinity. Remember, this was a separate section. It was not in chapter 1. So I want you to think of infinity as always separate. On this one, as we go to infinity, you want to compare these guys. And because they're the same, it's just the ratio of the leading coefficients, which is 3/2. Okay, lastly, looking at this guy, look up above at the 3 methods. What would work in this case? Before you do that, though, don't forget direct sub. If you plug a 7 in, you get 0/0. Remember, this guy's the problem. So to get rid of them, of the 3 methods, we're going to go with the middle guy, which is rationalizing. Remember, our goal is for this thing to go away, the x minus 7. So as we rationalize the top, we're going to get x plus 2 because that cancels, and then minus 9 all over x minus 7, square root of x plus 2 plus 3. And again, you know you're on the right track. You can see that this is x minus 7, which cancels, which was our goal. Now when you do direct sub, you are going to get 1/6, which is our answer. So far on this page, nothing new. Maybe you needed a little refresher on some things, but we'll get to the new stuff in a sec. Okie doke, on the next page. So here's a little history lesson. If you look at these guys, so one is L'Hopital and one is Bernoulli. Now the rule we're going to learn is L'Hopital's. However, if you look at them, one looks a little more sinister. And what happened was L'Hopital, even though it's claimed after him, he really didn't discover it, but he was the first one that published it. So Bernoulli, I believe Bernoulli was L'Hopital's teacher or tutor. Again, I'd have to look into that a little more. So you can see L'Hopital is over here. And then here's poor Bernoulli. So we can either call this L'Hopital's rule. This was Bernoulli's rule since he first discovered it. Either way, when you go to use the limit, and you get 0/0 infinity over infinity. So far to us, that meant algebra, rationalize, or common denominator. Now what we're allowed to do is you can take the derivative of the top and the derivative of the bottom, so the numerator and denominator separately, and then compare those. So looking at this first one, hopefully you recognize this from the first page. If we look over here, it was this guy, and the only way to do it was to make a table. Now what you're going to do is if you use direct sub and you get 0/0, you can use L'Hopital. So it's not quotient rule, even though you're dividing. What you're doing is you look at f turns into f prime. So you just take this derivative. Remember this derivative from chapter 5? It's copy it over and the derivative of the exponent over 1. Now what happened was a 0 used to be in the bottom, but when you took its derivative, now it went to 1. Now when you do direct sub, you get 3, which is exactly what we got in 1a. Okay, on this one, again, don't forget direct sub because sometimes that works. However, when you do it here, you get 0/0. So then when you take the derivative of the top, you get 1/2, 1 plus x to the negative half over 1. Again, the bottom went to 1. I don't care so much that it's 1. We just care that it's not a variable anymore so that when we sub it in, we don't get a 0. You might have to rewrite this just to make it look a little nicer, and then you get this. As x goes to 0, direct sub yields 1/2. So you can see L'Hopital saves us quite a bit of work, whether it was Bernoulli or L'Hopital, whoever did it, sure is helping us out. If you come over here, remember your natural log graph. I want you to have that memorized. It intersects at 1. As x gets huge, goes to the right. Now this graph is increasing super slowly, but it's increasing nonetheless. So the top is infinity, bottom is infinity. Infinity over infinity is another condition that allows us to use L'Hopital. So when you take the derivative, remember when you go to take this derivative that you're doing them independently. Again, here's chapter 5 back. The derivative is 1/x. Remember, this is really x to the half. So 2 is a scalar. The derivative is 1/2 x to the negative half. If you rewrite this, you can see that the 2 and the half cancel. So then I have 1/x times x to the half because that comes up, and you end up with 1/x to the half, or really it looks a little nicer if we write square root of x. And then as you look at this, now we no longer have x in numerator and denominator. We just have x in the bottom. X gets huge. This goes to 0. Okay, so that is how L'Hopital is working. If we get indeterminate, take the derivative of the numerator and denominator separately and then apply the limit. So looking at this next one, it's saying sometimes we have to repeat ourselves. That is not a typo. That was a little joke. So let's see if we can figure out what that means. So on this problem, if you sub negative infinity in, you're going to get infinity, and then the negative gives you infinity. So here's our ticket for L'Hopital. Let's try to zoom in a little bit on this. Okay, so as you're looking at this one, take the derivative of the top and get 2x. The derivative of the bottom, remember, copy it. And then the derivative of the exponent becomes a negative. If you sub negative infinity again, you're going to get negative infinity over negative infinity, which again is the ticket to use L'Hopital. So hence the repeating yourself up here is that we did it once, we didn't get a finite answer like we did up here. So we're getting this infinity over infinity, so you go ahead and do it again. The derivative of 2x is 2. This gets recopied, and the derivative of the exponent becomes positive. Now when you sub a negative infinity in, and remember this is like where we think, and then we probably would cross off our work because we really don't want to write this, but if you sub a negative infinity in, this becomes 2 over e to the infinity. This is huge, this is not, goes to 0. Okay, so on this one, we had to do it twice. Know that that's okay. Go through multiple iterations, but notice right here, as soon as we got something that wasn't infinity or 0 over 0, we had to stop using L'Hopital. Okay, this one, here's some trig. So you do direct sub. Here you also get infinity over infinity. So here's your ticket for L'Hopital. You get the limit as x goes to infinity over 2. Derivative of secant. Try on your own. Write down what you think. There we go, secant tangent. Hopefully you have that down. Derivative of 1 is a constant. That's 0. Derivative of tangent. Try doing that one. And it is secant squared. Secant cancels and the square cancels. If you plug pi over 2 in again, we're at infinity over infinity. So go ahead and L'Hopital again. The derivative of tangent, we just did it. Secant squared. Remember the square cancel out, so we just have secant, and that's secant tangent. That cancels, that cancels. So now look, we had tangent over secant, now we have secant over tangent. If infinity over infinity was an issue, of course this one is too. Now at this point, you don't want to keep cycling, right? You can see secant and tangent. This is now going to be chain rule. Well, no, I'm sorry, those cancel. But still, you're going to have derivative of secant, tangent, secant squared. It's just going to keep repeating. So think about one other method that might help. We don't use secant tangent a lot. Hopefully you're thinking to rewrite these guys. So this is just another trick. Remember on these problems, we're trying to put some on here that are a little tricky sometimes. This one's not as straightforward because it kept cycling, which is fine, but it's never going to stop. Whereas this one, if we look over here, if we can get there, it does stop at 0. Okay, so now that we're here, let's use this cleaned up version. And instead of secant, we're going to write 1 over cosine. And remember that canceled. And instead of tangent, we're going to write sine over cosine. Running out of room, so I'll write this way. If you multiply the top and bottom by cosine, they will cancel. So now you're left with 1 over sine. Think of your unit circle. If you're at pi over 2, sine is 1. 1 over 1 is 1. And ta-da! Finally done with that guy. Okay. Stay strong, kiddos. I'm about a third of the way through. Okay, now, let's see if I can move this up. I just wanted to review one-sided limits again. I know we don't see them as often. So looking at this one, if you try direct sub on this, you're going, remember we just try 0 first. If you're at 0, sign is 0, so we get 0 over 0, which is indeterminate. So then you're going to apply L'Hopital, and then we're going to get cosine x over 2x. Now here's the trick. So far, every time we tried L'Hopital, it's worked, and then as soon as we got a number, like above, we stopped. But right here, try plugging 0 in, and cosine of 0 is actually 1. So because you get 1 over 2, this is not indeterminate. So then this is where you have to think. So indeterminate did not work. Direct sub gave us this, which meant we can use L'Hopital. L'Hopital got us here. We cannot go further with L'Hopital. This is also not an answer. So think of 0 from the right. If you try plugging 0 in, we do get an answer of 1. So cosine of 0 is 1. Now this next one, remember this isn't like technically work, but you're just thinking through it. So 0.00001 times 2 is still an itty bit small number. So if we have 1 over a super small number, that's essentially infinity. Okay, the other one-sided limit, let's move this up, is right here now. So again, 0 from the left, try subbing 0 in. And sine of that is 0 over 0. So 0 over 0 indeterminate. Go ahead and L'Hopital it. And you get cosine x over 2x. Yes, it's just like the one on the other side, except that was from the right. When you plug 0 in, you're going to get 1 over 0, not indeterminate. That means don't use L'Hopital. So now you're thinking again. If I sub 0 in, cosine of 0 is 1. So you get 1 over a negative teeny tiny number, which gives you a negative infinity. Because 1 over small is huge, negative huge. Okay, so done with this page front and back. On to the next one, which I need to find. Just get it. If I don't find it, I will just put the answers up. Okay. I will post the second sheet in a second.